Welcome back. Now let's go ahead and take a look at some of the important properties of variables. The first thing that I would like to do is have a look at this. So quoting variables will actually preserve the white spaces. Here's what I mean by it. So if I declare a variable like this and I assign some sort of a value to it, tra la la, and then I use like 3 or 4 white spaces, la la la, and then again like this, L. It doesn't necessarily need to be in this format. This is something completely random that I have written. Write whatever you wish. But down below, if I type in echo $var, and here if I run it, you will see that not all of my white spaces have been preserved. Problem. Now this is why I said at the very beginning that it is a very good idea to always use the quotation marks, double quoting signs here when outputting variables with echo. Notice how it will change now. And if I run it, look, it has preserved all the white spaces here. Without any problems of whatsoever, they are all printed out just because I added quotes. However, if there is for example, if there is a white space within the variable, then it will need to be quoted. Now, if I just go back here, so let's say I wish to declare a variable, and I say equal. And then I do this, test 1, test 2, test 3. Okay, so this would be a correct declaration. And if I was to write this and run the file, you see it will output them normally and everything will be correct. This would also be correct. So if I remove these, no, it looks a little bit strange, but it should also be correct, at least to my know. Okay. Sorry. You need escape characters for white spaces here. Now let's go ahead and write. So this is also a correct way of writing it. So you see, again, we get a proper output, no problems. It all comes out. But what I have just done is what I have also wanted to demonstrate. If you remove these, and if you just declare a variable like that, like this, and if you save it, we will get command not found error. So this is an improper way of declaring it. You need to be a little bit aware of these things, how they work, and be aware that there are multiple ways of doing certain things. Different people code in a different fashion, and more often than not, you will actually be required to read somebody else's code, which is never a pleasant experience, believe me. I'm not just talking about Bash, this is in general for pretty much all the programming languages out there. It's never a good experience to read somebody else's code and to try to make sense of it. Anyway, you can also set a variable to null. So if you just delete this, and if you leave it like this, you can save it. This is also correct. Nothing wrong with this. Nothing will be outputted. The value is null, not the string null, not the value of 0, but the value is pretty. I do not know how to put this, but it's nothing. So the value is nothing. Let's put it like that. That's when you say null. Anyway, you can also set multiple variables on the same line. You can separate them with white space. So let's just go ahead and do this. Let's go into the insert mode. So I can say that var1 is equal to, I don't know, 10, 11, and var2 is equal to 22, and var3 is equal to 33. And if I go down, if I echo var1, and I do this var2, var3, you see, they are properly declared, everything works out. So you can you can declare them on the same line. Not the best of ideas, though. Let me just tell you that. You see, in the just a moment ago, I've shown you how just by not quoting a variable, sometimes it can display an improper output with white spaces because it omits certain things. But this can also cause some problems later on. You will see it as we continue to code. So it is way better just to do this. No big deal. It will not harm you or hinder you in any way. Just put every one of these into a separate line, and that is it. Nope, you will avoid a lot of headache at a certain point of time. Of that, I assure you. Okay, so no, we don't longer need these. Uninitialized variables. The one that I have just showed you has a value of basically it has a value of null. It will print out an empty line. So if we type in var equals nothing, echo, and then do this, var, and down below we can actually do this. We can set the var, so we can set the var to 9, and then echo var, run it like this, and you see the value will in fact be 9. Now what we can again do is set the value. We would like to change the value of the number. Oops. Var is now equal to 10. And now we shall like to echo. Now we will echo var again. So right. You see, now we have reassigned the value. First we have initialized it to null, then we have assigned 9, and then we have reassigned it to 10. We can even go ahead and unset the value. So we could actually just type in unset var. Sorry. We need to echo it out so that we know what has happened. Echo out var, and there you go. So it has we haven't initialized it to any value. It's basically null. And then we've assigned a value of 10. Then we've reassigned a value to 10, and then we have unset the variable, the value of the variable once again. I know, right? So very simple, no big deal. Just a list of these lines of initialization and unsetting the variable names, unsetting the variable values, and setting them to something else. This you will do very often. Uninitialized variables in an arithmetic operation, for example, if you were to add two numbers, let's say like this. If you're just wondering what is it. Okay, so var, and let's go ahead and type in that some var 1. We shall have var 1 that is equal to 10. And down below we shall say let var plus 10 echo. What would we like to echo out? So var plus 10. Actually, let's use this one. Let's not do it like this because I could have done it in a simpler way. I didn't need to use let here. I can do this. Look, pay attention. Var plus equals 10. We don't need var 1. What do you suppose I have written here? It's var plus equals 10. Well, this is the same as me writing var is equal to var plus 10. You see? Now, this will var, since it's uninitialized, since its value is null, this will be treated as a 0. So in arithmetic operations, this value is treated as a 0. even though when you echo it out, it echoes out an empty line. There's nothing on it. So 0 plus 10 is equal to 10. 10 is equal, now 10 plus 10 is 20, so we should echo out 20. Echo out var. And just to show you, we can do another echo here. So you can see how the variable changes. You see, it's 10 and then it's 20. It just goes one after another. This is how you can treat them. This is very important because since this is treated as a 0 in arithmetic operations, that means that when you multiply something, it will become a 0. Very important. Also remember that you cannot divide by it because you cannot divide by a 0. That's going to cause a lot of problems for you. Now we can assign a value to a variable as well using command substitution, but we have done a lot of that. However, well, we haven't done really a lot of it, but we did do a little bit. Let me just show you a few other things in regard to command substitution and assignment of values through such a process. So if we were to type in, I don't know, hi is equal to reversed quotes. Remember, we have used reverse quotes. I have explained what they are. And if I type in echo test, this is also another way of assigning a variable. And if I type in echo, and I would like to echo out the value of hi, this will give us test. So it will take this value and put it into this variable here. This is also another way of assigning the value of a variable. There are more practical examples than this because this is just an echo command, but you can also use this ls home. Look, you can combine it with Linux. You can basically combine it with the commands that you use and get their output. So ls home chronic, and this should be enough. Let's say, look, I have now gotten the list of all the folders and files. Well, not all the folders and files, there are some hidden ones, but I could have passed in different arguments. And they are all stored into a variable, which I can now manipulate, which I can now play around with, which I can customize to suit my particular needs. Now, there are some cases where you can actually use parentheses as well, like this. So if I just remove this, and I can still use the ls command, it's a fairly straightforward and a simple example, and I can remove the quotation marks. I can just open the parentheses and close it, and if I type in -la down below, I shall simply echo it, no big deal. I know that I have a stupid variable name hi, but oh well, no big deal. You see, now this will not work. Why won't it work? What are we missing here? Can anybody see? Well, we need a $sign here, and we need a $sign here. Why? Because this is a variable, and now we have performed some sort of an operation here, and we would like to take the result of that operation, convert it into a reference value, and place it as the value of this variable. And if we do it, you see, I will get the long listing of all the folders and files, all the ones that are hidden and that are not hidden. Very simple. So L is for long listing and A is for all. Bash variables, they don't have a type, which is very convenient for us as the users, but not so convenient for the machine, as these kind of things can be expensive in terms of RAM. They are the variables here, as they don't have a type, they are character strings by default. However, it is possible to perform arithmetic operations and comparisons if all characters are digits as well. This we will see in the follow-up examples, but before I go there, let me just tell you why, what these types are. For example, you have in C programming language, which is a lot faster than Bash, you would have, but look, I just say that it's a lot faster than Bash, but doesn't necessarily mean that it's better or worse. Why? Well, C is meant for a certain set of things, for a certain set of tasks, and Bash is meant for another set of tasks, which would be ludicrous to do in C, and there are certain tasks which would be ludicrous to do in Bash. Simple as that. So, what are these types? You won't need them in Bash, but I figured it would be nice for you to know. You have an int, you have a string, you have a char, you have a float, double, not sure which one. I think actually this is pretty much enough. There are definitely more than this, but it's okay. So what is an int? It represents an integer. Integers are numbers like 1, 2, 3, 4, 5, 6, etc. If you don't know what an integer is, well, just use your favorite search engine and look for it online. It's an English word, nothing else. You use it, I do believe that everybody has mentioned it 100 times through elementary school. String. String is something like this. You put it in quote marks and then you say, hey, how is it going? What on earth is going on? So this is a string. And down below, a char would be a single letter, so A, or B, or T, or something like that. A floating point would be 1.345, something like that. So with the, these floating points, basically floating point numbers. Sorry, not. My bad. This floating point number would not be this. This would be double. Floating point number would be 0 in front, and then dot, and then the numbers behind the dot. And down here, the double would be 1 point something, or I don't know, 10 point something, etc. You get the idea. Why is this important? Why would anybody want to declare? Why would anybody use these? Well, in C, you would say, instead of writing, you would say int var, and then var is equal to 10. And this var can only be an integer. It cannot be anything else. Why is this important? Well, because all of these things, when you declare them, they reserve memory space. It is not significant for you now, but in huge lines of code and for an operating system or something like that, it is the difference between using larger amounts of RAM or lower amounts of RAM, which is very, very important resource-wise. For example, integer will take far less RAM when declared as opposed to a string. A string will take a lot more RAM than an integer. And so on and so forth. All of these values, all of these variable types, they will take different amounts of, they will reserve different amounts of RAM, because when you start a program, the compiler will go through it, the machine will go through the code and will say, okay, I have an integer there, string here, etc. Reserve this much RAM for the integer, reserve this much RAM for string, etc. And the rest of the machine will not be able to access that amount of RAM. These are very small amounts of RAM. They're like very, very, very small. I'm not talking about megabytes, I'm talking less than megabytes. So you don't have to worry about it that much in Bash. But when you're writing a code for an operating system or for a game, it is very important to play around with these things. But in Bash, for example, if you just wanted to use some scripts to install a program or something like that, obviously this will not play any sort of a role pretty much. Anyway, we will continue on with these arithmetic operations and comparisons in the follow-up tutorial, as I am running a little bit short on time here. I just wanted to tell you what these types are, even though you won't encounter them much or at all in Bash.